is Chapter 9, Section 5, Geometric Series. Our learning objective is to define geometric series and find their sums. Let me highlight what you need for essential understanding. Just with finite arithmetic series, you can find the sum of finite geometric series using a formula. You need to know, that's the essentials. You need to know the first term, the number of terms, and the common ratio. So you need 3 items to use the formula. A geometric series is the sum of the terms of a geometric sequence. And I remember the difference between arithmetic and geometric. Arithmetic starts with an A. A is for adding. That's what we do each time. We just add the same number. And then geometric is the other one. He's the multiplying guy. So the sum of a finite geometric series, so remember finite means it's got a beginning and an end, doesn't go dot 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 forever, is the first term times 1 minus the common ratio to the n power, all divided by 1 minus the common ratio, where A is the first term, R is the common ratio, and M is the number of terms. Alright, so let's see how this formula works in practice. Question number 1A says, what is the sum of the finite geometric series? The first term is -15. The number of terms is 1, 2, 3, 4, 5, 6. So n is equal to 6. And then what's the common ratio? Thankfully they already told me it's geometric, so I can easily find the common ratio by taking our current term. So if I take 30 divided by -15, and I get -2, and let's double check that. If I multiply by -2 each time, do I get the next one? Yeah, that's how we roll. So our common ratio is -2. Alright, so this is going to be some calculator magic today. Figuring out how your calculator wants to deal with fractions, the denominator and the numerator, and the exponent is going to be probably the trickiest part. Plug it into the equation, that's easy peasy. So the sum of the first 6 terms of this sequence is the first term times 1 minus the common ratio raised to the 6th power divided by 1 minus the common ratio. So that's a lot of integers and number dealings going on. So I'm going to simplify it down a little bit. -2 to the 6th power is 64. I know I have that memorized, so that's scary. It should be scary. So then this is 1 minus 64. Divided by 1 minus -2 is the same as plus 1 plus 2, so that's 3. Keep simplifying it down. I can actually do -15 divided by 3. I can do this math right away, so I know what that is. And then 1 minus 64 is -63. And then it's just a calculator jug. Sorry, I'm not smart enough to do that in my head. 315. So the answer to this question is 350. That's it. All right, so what if we have it in sigma notation and not listed out as the numbers? No worries, because sigma notation, we know that our first term is whatever this is when we plug in 1. So we just go 5 times negative 2 to the 1 minus 1. 1 minus 1 is 0. Anything to the 0 power is 1. 5 times 1 is 5. So the first term is 5. Our common ratio is the guy that is being raised to the exponent. So in this case, it's negative 2. Yeah, it's negative 2 again. And then the term that we're going to, in sigma notation, they write it in that upper limit. All right, now we have all of our pieces. We can put it into the formula. So the sum of the first 10 terms equals 5 times 1 minus the common ratio to the 10th power divided by 1 minus the common ratio. So I'm going to go negative 2. Let me show you a cautionary tale. When you have negative 2 and you're raising it to the 10th power, you have to be careful. This calculator took the negative 2 as in parentheses, but some calculators will apply the power first and then the negative at the end. So just make sure your calculator is giving you the right answer. Since this negative 2 is inside and it's being raised to the 10th power, I know my answer is going to be positive. So this is 1 minus 1024. And then my denominator is 1 minus negative 2, which is the same as 1 plus 2, which is also known as 3. So if I were to go 1 minus 1024 times 5 divided by 3, I get negative 1,705. Is that negative? Double checking. Negative. So it's negative 1,705. Okay. Infinite geometric series. So you can actually find the sum, this may sound crazy, of an infinite geometric series. I know, my mind is blown. If this series keeps going for infinity, how can it have a sum? Well, think about it in like this. If our common ratio is less than 1, so if the absolute value of the common ratio is less than 1, it has a finite sum, and we can use this formula. If your common ratio absolute value is greater than or equal to 1, it does not have a finite sum, and this formula does not apply. So if we are multiplying by 4 forever, our sum would keep growing forever and ever. But if we're multiplying by 1/2, forever and ever. At some point it would converge to a number. So to say that an infinite series, a1 plus a2 plus a3, has a sum means that the sequence of partial sums, s1 equals a1, s2 equals a2, a1 plus a2, s3 equals a1 plus a2 plus a3, and so on, converges to a number s as n gets very, very large. When an infinite series does not converge to a sum, the series diverges. An infinite geometric series with r greater than or equal to 1 diverges. So when your common ratio is between 0 and 1, your sum is going to converge to a value. But if it's bigger than 1, it just goes on forever. All right, let's see how that works. Does the infinite series converge or diverge? If it converges, what is the sum? So we need to find the common ratio to see if it converges or diverges. And then if it converges, then we need to find its sum. So do you guys remember how to find a common ratio? We divide. So I'm going to take 3/4 and divide it by 1/2. And just for fun, we're going to do this little fraction exercise. 3/4 divided by 1/2 is the same as 3/4 times 2 over 1, which then gives us 3/2. 3/2 is our common ratio. That's equal to 1.5. Is a 1.5 less than or bigger than 1?
Bigger.
It's bigger, so this diverges. There is no sum. So let's look at B. We're going to do the same thing. We got negative 1/9 divided by 1/3. Negative 1 over 9 times 3 over 1. That would be negative 1/3. Is the absolute value of this less than 1? Absolute value of negative 1/3. So this converges. And because it converges, let's use the formula. So the sum of this guy is equal to our first term over 1 minus our common ratio. 1 minus negative 1/3. Minus and negative is the same as plus. So that's 1/3 over 1 1/3. Oh my gosh, that's crazy. Because I'm a little bit of a fractionophobe, I just made that. I'm going to do it in my calculator. So 1/3 divided by 1 1/3, isn't that 4/3? Wait. 1/3 divided by 4/3. Thank goodness, it's 0.25. What's that as a fraction?
1/4.
1/4. Thank goodness. We don't have to do the math. So the sum, because this converges, its sum is equal to 1/4. Please, if you would like help on your calculator, every scientific calculator has a fraction button, and I would love to help you with fractions, because the point is not, can you manipulate fractions? Our learning objective is, can you identify geometric series, no infinite. So if you want help using your calculator, or there's an online fraction conversion tool, let me know. I'll help you guys out with that. I don't want you to get hung up with fractions. All right, last one. This one is C is in sigma notation. Well, we know it's infinite because look at our upper limit. It says the sum, that's what sigma means, of n equals 1, so we're going to start at the first term. We're going to go forever to infinity, of 2/3 to the n power. What did we say? If we look back at the one before, this scenario, which was our common ratio? Yeah, inside the parentheses with the exponent. So if we apply that same pattern to here, what's our ratio going to be for C? 2/3. So C, we know that our ratio is 2/3. Identify that, compare that to, is the absolute value of that greater than or equal to 1 or less than 1? 2/3. It is less than 1, so this one definitely converges, so we're going to find the sum. And like we took notes on up here, we're going to need the first term and then the common ratio, and we're good to go. So the first term is what we get when we plug in 1 for n. Yeah, it's got a lot of 2/3 running around here. So the sum is the first term over 1 minus the common ratio. One minus 2/3 is like 3/3 minus 2/3, which is 1/3. Dividing by a fraction is the same as multiplying by its reciprocal. And we get that the sum is equal to 2.